So very good evening, one and all present here. So we are in module 5. So in basic applied mechanics under module 5. In today's section, we are going to see about the triangular law of forces. Next concept. In the previous session, we saw about parallelogram law of forces. In that order, the next basic principle under law of mechanics, triangular law of forces. So what is the proposed statement given by? So take two force vector P and Q, both the force vector acting simultaneously at a particle at a point O, where theta is the angle between the two force vector. So consider the two forces acting simultaneously on a particle represented in magnitude and direction, which forms the two sides of the triangle. Okay. Where R is the resultant, which forms the third side of the triangle, which is taken in opposite order with magnitude and direction. So this is the proposed statement of triangular law of forces. So if there are two force vector P and Q, we have to find out what is the resultant of the two force vector P and Q by constructing the triangle forming three sides. Now let us see the steps of construction one by one. Let P and Q are the force vector acting at point O. So from the given diagram, P and Q are the force vector which is placed at a point O. Theta be the angle between the two force vector P and Q. Now change the position of the force vector P and Q in order to examine the resultant force R. So from this diagram, you change the position of the force vector, okay, by constructing line OA and AB along with the force vector P and Q. Now draw OA and AB with force vector P and Q. From O, draw a line OB to represent the resultant force. So from the point O, construct a line OB. This is said to be resultant force. Okay, now the resultant force is placed in opposite order of the force vector P and Q. And this is the third side of the triangle as per the given statement. Now applying the mathematical relation, so this can be constructed in such a way, considering P force vector P by OA. The OA represents the scaled dimension of the triangle, the base side of the triangle. Force vector Q by the side AB, R resultant force R by OB. Okay. So the corresponding force vector and the side edges of the triangle are represented in this relation. So this is the equation which is used to derive the mathematical relation for triangular law of forces. Now let us take a practical example in real time how we can apply the triangular law of forces. So in yesterday, we took an example of a tabletop disk in parallelogram law of forces. Similar to that, here you take a box, a cardboard box, which is supported on a floor horizontal surface. So the box is being pulled by two forces, F1 and F2, in opposite adjacent direction. So here we can construct a force vector diagram by applying triangular law of forces to determine the resultant force acting on the box. So this is a simple example in real-time application. So how to practically apply the steps of triangular law of forces in real-time situation. So with this, I thank each and every one of you for your continuous support. The next class, we will discuss the remaining topics in applied mechanics. So thank you one and all present here.